we'll just have to see how this goes. What I've done this evening, sorry, excuse me, is I've chosen some questions that are also going to be a little bit more challenging. All right, maybe not the first question, but the second question. So if we look at question 5.1, question 5.1.1 would be easier. And then question 5.1.2 is going to be a little bit more difficult. Okay, all right, so let's continue with what we're doing. All right, so in 5.1.1, they ask us to simplify the above expression to a single trigonometric ratio, right? So we have got sine 180 minus theta. Let's just get this question down. Multiplied by cos 90 minus theta minus 1 in the numerator. And in the denominator, we've got cos minus theta. All right, so there are two terms in the numerator. So sine 180 minus theta times cos 90 minus theta is the first term, and the minus 1 is the second term. All right, so what are we going to do with sine 180 minus theta? How are we going to reduce that? What would it reduce to? Sine 180 minus theta is going to reduce to what, matrix? So think about your grade 11 reduction formulae. What's it going to reduce to? Please share your answers in the chat, or if you want to unmute and speak, you're very welcome. But I really want to hear what you guys think instead of me just telling you all the time. What are we going to do with sine 180 minus theta?
Let's go and check.
Okay, so a couple of people have said negative sine theta. Lihu has said positive sine theta. So 180 minus theta is which quadrant matrix? 180 minus theta is which quadrant? It's the second quadrant. Good. It's the second quadrant. Is sine theta positive in the second quadrant, or is it negative in the second quadrant? It's positive. Yes, well done. Okay, so this is going to reduce to positive sine theta. Okay, important we'd get a mark for that, but we'll talk about the marks at the end. Okay, now the next one, cos 90 minus theta. What's that going to reduce to? Cos 90 minus theta, what is that going to reduce to, matrix? No iPhone, so 180 minus theta is the second quadrant. So in the second quadrant, sine theta is going to be positive. So no, it's not negative. Okay, think about your cast diagram. Okay, so this quadrant over here, the second quadrant is 180 minus theta. Okay. All right, so let's just have a look there. Molebo says it needs to be sine theta. Good, Molebo. All right, this is a co-ratio. So cos 90 minus theta becomes sine theta. Well done. There's our minus 1. All right, and now into our denominator. Here we've got cos minus theta. So what is that going to reduce to? Is it going to become positive cos theta? Is it going to become negative cos theta? How do we know? Think about our cast diagram. Which quadrant we're in? What do we do with cos minus theta, please, matrix? Okay, add 360. It's not necessary, Lichlu. It's not necessary to add 360. We can just write down the answer straight away. What are we going to do with cos minus theta? Okay, all right. I see what you're thinking here. Okay, now Lichlu's given me an answer, but what about the rest of you? Okay, there's another 33 of you out there. Which quadrant are we in? With cos minus theta, which quadrant is that? Good, Katlejo. You certainly can, Lesejo. Good, well done. Thank you for your answer, Lesejo. Okay, so we're in the fourth quadrant. So we would write this as positive cos theta. Good, well done. Okay, so now we can simplify our numerator a little bit. We've got sine theta times sine theta. So that would give us sine squared theta minus 1 over cos theta. So now obviously we need to do a little bit more simplifying. What do you think we should do to the numerator? There's two different things we could do. What would you guys do? So Anaka, why is it cos theta? Because of your co-functions. Okay, remember when you have 90 minus and 90 plus, cos theta and sine theta change. Okay, so cos theta changes to sine theta, and sine theta changes to cos theta, so your co-functions. Okay, Zwanaka, that's your grade 11 trig. Does that make sense now? Why is it not negative? Okay, because 90 minus is the first quadrant, and all trig ratios are positive in the first quadrant. Okay, so the only time it becomes negative is if you've got cos 90 plus theta. That's negative. Okay, because cos theta is negative in the second quadrant. 90 plus is the second quadrant. 90 minus is the first. So this becomes minus sine theta. Okay, Zwanaka? All right, so ideas with what to do with the 1. What can we do with this 1 over here? Miss Cindy says change sine squared theta minus 1 into cos squared theta. Okay, we've got to do something to it first before we're allowed to do that, Miss Cindy, because remember, cos squared theta is 1 minus sine squared theta. That's okay, Swanaka. Okay, so you guys are saying take out the negative. Cool, that's one way we can do it. So let's take out the negative. That gives us 1 minus sine squared theta. Cool, I'm happy to do that. Over cos theta. I'm going to continue to write up over here. So then at the top here, we'd end up with negative 1 minus sine squared theta is negative cos squared theta. And there we go. All right. Now we've got negative cos squared theta divided by cos theta. So this would leave us with negative cos theta. Okay, is everybody happy with that? Our alternative at this point over here where the pink is, we could also do this if we wanted. So we've got sine squared theta, and now we're saying minus 1. So what we could do is we could write the 1 as sine squared theta plus cos squared theta. You can also do that if you want to use your square identity over cos theta. This would leave sine squared theta minus sine squared theta minus cos squared theta over cos theta. And sine squared theta minus sine squared theta is 0. So you'd end up in the same place with negative cos squared theta over cos theta, which would then also become negative cos theta. So that would be an alternative way of doing it from there. Probably a little bit quicker to do what we did where we factorized, but both methods would be acceptable. Everybody happy with that so far? Is that making sense? Yes. Good. All right, lovely. So let's just have a look at where the marks would be allocated for this question before we do go and worry about question 5.1.2. All right, so we've got 5 marks here. So whenever we apply a reduction formula, we're going to get a mark for a question like that. So sine 180 minus theta, we'd have a mark on sine theta. We'd have a mark on that sine theta over there. Potentially, they could give us a mark on that cos theta at the bottom. Then they could give us a mark for taking out the negative, and then a mark on the answer. I'm guessing perhaps they, at matric level, they may not have awarded this first mark over here. Perhaps they would have awarded an accuracy or simplification mark over there, but it really doesn't matter. Okay. All right, let's have a look at the next question. So question 512 begins with the word hence. So in maths, when a question says hence, what do we have to do? When a question says hence, what do we have to do? What do we have to do? Zedalia?
Hi, Mom.
Hi, Zedalia. How are you?
I'm good, and you?
I'm fine, thank you.
Ma'am, what I think you need to do is from the previous question, you need to use what you've proved there to solve the next question.
Exactly, 100% correct. Okay, you've got to use your previous answer. Okay, and not just Zedalia saying that, some other people, Macindy, you've said the same thing, Chad said the same thing, and Kanyiso said the same thing. Well done, all 4 of you. Oh, where did that come from? I don't remember asking for a ruler. Hold on, guys. Hang on a second. I must have clicked that button. Okay. So yes, we have to use our previous answer. Now, can you see, everybody, that the expression that they gave us is now inside a square root? Look, it's exactly the same thing. We've got sine 180 minus theta times cos 90 minus theta minus 1 over negative cos theta. It's exactly the same as what they gave us over here. Right? So when they say hence, they want us to take the answer that we got and put it inside that square root. Okay, so now in question 5.1.2, they want us to determine the values of theta between 0 and 360 for which the square root of negative cos theta will be real. Okay, so in order for numbers to be real, what is the condition when something is inside a square root? What's the condition for something inside a square root for things to be real? Anything that is inside a square root has to be? Absolutely. So it's allowed to be 0, but it's got to be greater than or equal to 0. Okay, so for real numbers. Okay, now what is not obvious to us here is that they are linking this question to our knowledge and understanding of the cos graph. So just very quickly, I'm going to show you what I mean. So let's draw ourselves a set of axes, okay? And we really are only concerned with what's on the right-hand side. So let's say over here, if we had 90, And there we had 180. And here we had 270. And I didn't make it long enough. And here I have a little bit too far away. Let's do that in blue as well. Let's say over there I had 360 because they said here that it was hence determined the values of theta between 0 and 360, for which this expression will be real. So in other words, whatever goes inside this over here has to give us a positive answer or something equal to 0. Let's think about what the negative cos theta graph looks like. Okay, so it's the cos x graph, except instead of it starting up here at 1, it's now starting here at -1. And then it's going through 90. It will now have a maximum at 180, another x-intercept at 270, and then it'll be back down to its minimum of -1 at 360. Is everybody happy with that? So that is the graph of y equals minus cos x. So if we want to get rid of this negative inside here, this negative over there, if we want to make it positive, we can do that by multiplying a negative with a negative. Okay, so let's have a look. What happens at 0 degrees? Remember, this is 0 degrees over here. What happens at 0 degrees? What is cos theta equal to? It would be equal to -1, absolutely, right? Would that give us a positive inside here? Okay, so if theta equals 0 degrees, it means that negative cos theta, okay, would be equal to -1, which would give us +1 inside our root. So it works at 0 degrees. Okay. Yes, lovely. All right. Okay. So the next point that we get to that I suppose is of significance for us is when we get to 90 degrees. All right. What's going to happen at 90? So if theta were to be equal to 90 degrees, we would have negative cos 90. So what would that give us? It would give us 0, absolutely. That would give us 0. So that's also okay. So between 0 and 90 is fine. Now, what happens if we go and we sub in 180? If theta was equal to 180, what would happen? We would have negative cos 180 So now we're going to end up with a negative answer. Okay, the cos of 180 is 1, and 1 times -1 is going to give us -1. Are we happy? If we put -1 inside our root, is it going to be real? Is our expression going to be real? No, it's not. Okay, so what's happening here is that as long as our output numbers are negatives, we are going to get a negative times a negative, which will give us a positive inside our root. So what we are seeing is that between 0 and 90, minus cos theta or root minus cos theta will have a positive value. And as long as it's a number that's bigger than 270 but smaller than 360, we will also have a positive value inside of that root. Does that make sense to everybody? So in other words, it makes sense. Okay, so in other words, all right, if we want it to be real, the values of theta between 0 and 360, and can you see here, they've included 0 and 360 in our answer. So what we can do here is we can say, all right, so theta needs to be a number that is greater than or equal to 0 degrees, but smaller than or equal to 90, because remember at 90 it was equal to 0, and that's okay. Or theta needs to be greater than 270, but smaller than or equal to 360. So anywhere between 90 and 270 will give us a negative inside of our orange square root. Okay, are we happy with that? So this is out of 2 marks. When you write an inequality like this, it can only be either perfectly correct or incorrect. There's no other, what you can't get part marks. Okay, so it's going to be there or there. You could also write it with brackets if you wanted and write it as a union. Okay, that would also be acceptable. So if you wanted to say x is an element of square brackets from 0 to 90 union 270 to 360. That's just a different way of writing the same thing. Okay. No, you don't have to show the calculations. I was just doing this over here to explain where my answer comes from. All right, so this would be answer only. Okay. Chad, why are 90, 270, and 360 included? Okay, so Chad, the reason that I'm including 90 is because at 90, y is equal to 0. So cos theta is 0. -1 times 0 is 0. So it'll still be real. And it would be the same at 270. It would still be real. Okay, because it would still be 0. Okay. Does that make sense? No problem. Okay. All right. So Sydney, I know you've just joined. Unfortunately, you've missed this question, so you're going to have to go and watch the video. I'm going to go and move on to the next question now, so don't stress about that. Okay. So again, I'm doing slightly more difficult questions with you today. I'm not doing the basics. I wanted to try and give you guys a bit of a challenge. Let's have a look at the next question. All right. In 5.2, it says determine with the aid of a diagram and without the use of a calculator, the value of cos alpha if sine 2 alpha equals 15/8 and 2 alpha is an angle between 0 and 90. Iola, all the videos are on the website. Okay, so if you log onto the website, I personally, neither Yolanda or I don't know if Yolanda can actually, but I know we can't log onto the website as a student the way that you can. So
Yeah,
I don't know.
Details, yeah.
Yeah, but if you log onto the website, it's very, very easy to find. Okay, probably easy if you go on a desktop or a laptop rather than a phone. Hey, but I mean, if that's not possible, you can use your phone.
Yeah, and also there's a YouTube, Watobe's YouTube also. So you can watch all the videos are there for grade 12. So you can watch it also online.
Oh, there we go. Yeah, absolutely. Katlego, you want to ask a question?
Ma'am, if you click on the link again
Yes.
tomorrow, it's going to watch video, so she's not going to struggle.
Okay, cool. All right, there you go. I hope Sydney you heard what or no, I think it was Iola that asked where we could find the video. Okay, Iola, there we go. All right, so let's go and have a look at this question. Now, what makes this question a little bit more challenging is they want cos alpha, but they give us sine 2 alpha. Okay, so this is a question about Pythagoras with a twist. Let's start off. We've got sine 2 alpha is equal to root 15 over 8. We know that the sine of any angle is always y over r. So what they are telling us in this case is that y has to be equal to root 15, r is equal to 8. How are we going to work out what x is? What would we use to work out the value of x? Matrix. If we know what y is and we know what r is, how would we work out x? Absolutely, Molebo. Everybody else, what are we using? Good iPhone. Good in Kanyiso. Okay, we're going to use the theorem of Pythagoras. But before we do that, they tell us that we have to do it with the aid of a diagram. So they expect us to draw a diagram. Okay, no compound angles in this case. They expect us to draw a diagram. So our angle is between 0 and 90. So in other words, 2 theta is an angle in the first quadrant. So there it is. There's our angle 2 theta. And what they expect us to do is label the angle when we draw the diagram, and we also want to fill in some information. So what's missing here is our x coordinate. We know what our y coordinate is, it's root 15, and we know the length of the terminal arm r is equal to 8. Now, okay, thank you, Chloe. Lovely. Chloe's given me the answer. Now we're going to do the theorem of Pythagoras. So we say x squared plus root 15, because that's y squared, equals 8 squared. I cannot emphasize enough how important it is that when you substitute in brackets and you put exponents on the outside. Okay, so we've got x squared plus, this will give us 15 is equal to 64, and x squared is going to be equal to 64 minus 15, so that's going to leave us with 49. And now we need to be careful. We're working in the first quadrant. So when we take the square root of x, we would normally always have to be aware of which quadrant, well, we always have to be aware of which quadrant we're working in, but because we are working in the first quadrant, x would be equal to +7 instead of -7. Okay, so we've worked out y is root 15, r is 8, and now we know that x is equal to 7. Quite right, Chloe, you sent me the right answer. Perfect. So now we've done all of this, okay? They want cos theta. Okay, so Miss Cindy's already suggested an answer for cos theta, 7 over 8. Miss Cindy, you're going to have to explain to us where you got that from. But hang on a second, Miss Cindy. Wait. Okay, if Miss Cindy says cos theta or cos alpha is equal to 7 over 8, that's not true, because remember, we're working in terms of 2 alpha in the diagram. So it's not cos alpha that's equal to 7 over 8, Miss Cindy. It's actually cos 2 alpha that's equal to 7 over 8. Okay, so this is the twist part. Remember I said to you that this is Pythagoras with a twist. Okay, so we've done the Pythagoras part. We've got some marks for this question, but now the real thinking starts. No, now why not, Zedalia? If we double the angle, do we double the ratio? Think about your graph. Okay, so if we think about our cos graph, Zedalia, I'm so glad you asked that question. Our cos graph looks like this, doesn't it? Okay. In fact, we're working with negative cos x up there, but let's just draw a cos graph over here, okay? And our x coordinate would be over there, all right? If you consider 30 degrees, okay? So the cos of 30, in fact, we don't even need the graph. Let's just do it this way. Hang on a second. Okay. If I double the angle, do I double the ratio? I can't, because I'm working along a curve. So think about it. The cos of 30 is what? The cos of 30 is Root 3 over 2. What is the cos of 60? I've doubled the angle. Do I double the ratio? The cos of 60 is equal to 1 over 2. So if I double the angle, can I double the ratio? No, I can't, because I'm working along a curve. Okay, no, that doesn't work. So now I need to start thinking about my formula sheet. All right, what on your formula sheet, your double angles, what is cos 2 theta equal to? No problems, Adelia. What are the three options? What is cos 2 theta equal to? Or cos 2 alpha? It's equal to, there can be three, quite right. Aha. So now Pinga says 2 cos squared alpha minus 1 would be one of them. Or we could have 1 minus 2 sine squared alpha. Or if we wanted, we could have cos squared alpha minus sine squared alpha. We want cos alpha, not cos 2 alpha. We want cos alpha. So the only one of these three options that contains cos alpha, even though it's cos squared alpha, is the first one. Okay, so what we want to do here is we want to rewrite cos 2 alpha as 2 cos squared alpha minus 1. That's the twist. Okay, and now we are going to solve for cos alpha. Okay, so we've got to take the 1 over to the other side. That gives us 2 cos squared alpha is equal to 7 over 8 plus 1. So that would leave us with 15 over 8. Now we have to divide both sides by 2. So that would be 15 over 8 divided by 2. Let's just, oh man. That would be 15 over 16. And now we are almost there. Okay, to get cos alpha on its own, we have to take the square root. So it would be the square root of 15 over 4. Okay, square root of 15 over 4 when we take the square root on both sides. Okay. Are there any questions? No. Okay. So in the day-to-day teaching, when you did trig at school, your teachers should have shown you this sort of question that I've just shown you now. Okay. So if they give you a double angle, like they did in this case where they gave us sine 2 alpha, and they want us to go back to either cos alpha or sine alpha, okay, from a double angle, we've got to use cos 2 alpha to do it. Okay, because cos 2 alpha is the only one that can be written in terms of either cos alpha or sine squared alpha. It's not going to help you to rewrite cos 2 alpha as 2 sine alpha cos alpha, because to get sine alpha, you need cos alpha, and to get cos alpha, you'd need sine alpha. All right, so that's the trick here. They give you a double angle, and then they want cos alpha or sine alpha from that. You've got to use cos 2 alpha. Okay, so if they wanted cos alpha, we'd use this one. If they wanted sine alpha over here, we'd use that one over there. Okay, all right, so that was out of 5 marks. Okay, so what do we need in order to be able to answer this question? Well, we need 7 over 8. We need to know what cos 2 alpha is equal to. So they said we need to draw a diagram. There we go. Don't forget you must label your angle. We'd need a value for x. we'd need to know what cos 2 alpha is equal to using our identity. How many marks have we got? 1, 2, 3, 4. And I suppose at matric level, they're not going to give us any marks for simplifying. They would then give us a mark on the answer like so. Okay. All right. Now let's go and have a look at the next question. So here it tells us without the use of a calculator, determine the value of the cos of 0 plus the cos of 1 plus the cos of 2 plus the cos of plus the cos of 178, the cos of 179, the cos of 180 plus 2. All right, so what do we think is going on here? Indeed, Pinga. Some kind of interesting number pattern has to be emerging here. What I'm going to do is just quickly snip this question, and then we can, it's out of 3. So just snip that, and let's just paste it underneath so we don't have to keep going up and down and up and down and up and down, because that's a bit irritating. Okay, so Pinga saying x plus 1 for each term. Not quite, not quite. Think about it a little bit more. So we're not allowed to use a calculator. Does anybody know what the cos of 1, or sorry, I beg your pardon, what is the cos of 0? That's what I meant to say. What is the cos of 0 equal to? Okay, all right, lovely. Okay, so the cos of 0 is equal to 1. Then we've got all of these terms on the inside. Then at the end, we've got the cos of 180. What's the cos of 180 equal to? Good. Okay, it's eventually something like that, Chad. Good, well done. So now here we're going to have a minus 1. So this 1 at the beginning and this minus 1 over here. So this one over here and that one over there are going to end up cancelling each other out. Plus we've got a 2 at the end. All right, so we've dealt with the values that we know. We know about the cos of 0, we know about the cos of 180, and we've included our 2. What are we going to do with the other numbers that we've got? What are we going to do with the cos of 1 and the cos of 2? What do you think we should do there? Almost, Pinga. You're getting very close. Good. Well done. You're starting to make connections. Good. So, Pinga, what I want you to do. Okay, so Chad, you're very close. Very, very, very close. So, I don't want to tell you the answer. I just want to give you guys a chance to think about it. Let me give you a minute or two to think about what you're going to do here. But you guys are very close. Chad and Pinga, very, very nice answers. And when, if and or when I tell you without you figuring it out, you're going to be like, oh, I should have thought of that. It's one of those sort of things. Oh, okay, hang on. Okay, iPhone, you are very, very close. You are just, yes, Jude, we would do that. We would work from this end, this end, this end, this end going in. Quite well. Isn't it in the proof? This is not the proof, Sedalia. This is not a proof. So what is the connection? Let's get rid of the cos 2 over here, or highlighting it. What is the connection between the cos 179 and the cos 1? You're on the right track, Chad. We know that if we add 1 to 179, we get 180, don't we? Exactly, right? And the same story over here. If we've got the cos of 2 and we add 2 onto that, we're going to get 180. Right, so what I'm going to say now, let's see if you can make the next step. Think about your reduction formulae. Hint, 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 hint. Aha, Lasejo, there we go. Okay, there we go, Lasejo. Nice. Okay, so all of you kind of work together. All right, brilliant. Okay, Lasejo has hit the nail on the head here, all right, and has said, ma'am, can we say cos 180 minus 1? Yes, absolutely, we can. Okay, so in other words, what we're doing here is we're actually using our reduction formulae. Okay, so in other words, you can write the cos of 179, for instance, as the, sorry, I should have written a bracket first, as the cos of 180 minus 1. Does that make sense to everybody? So now applying our reduction formulae, what would the cos of 180 minus 1 reduce to? What would it reduce to? There we go, Lucejo. It would reduce to negative cos 1. Okay, so now here you've got plus, just as you guys were saying, Chad, Pinga, you were all coming up with this. So now you've got plus cos 1 over here, but over there with cos 179, you've now got minus cos 1. Okay, and then the same thing would happen with the cos of 178. The cos of 178 is the cos of 180 minus 2. So this would reduce to negative cos 2 degrees. So now you've got plus cos 2 on that end, and on this end you've got negative cos 2 degrees. Is the pattern starting to emerge? Is it starting to make sense? Matrix, is it starting to make sense to you? Yes, they're starting to see the pattern here. So all of the terms between cos 1 and cos 179 are going to add up to 0. Okay, because this term over here and that term over there will add up to 0. This term over here and this term over here are going to add up to 0, making so much more sense. Okay, so also the one at the front from cos 0 and the negative 1 over here from the cos 180 are also going to add up to 0. Okay, so Pinga, you were right. Okay, it's going to add up to 2. Okay, and everything else is going to cancel out. So our final answer, yes. Our final answer would be 2. Okay, so the key really to this question is understanding that you can rewrite cos 179 as 180 minus 1, which is negative cos 1. Yes, Sedalia, go for it.
I'm sorry, ma'am. I just wanted to find out,
Okay.
would you still get all your marks even if you just wrote 2? Or does it depend on the marker?
I think you'd probably get maybe 1 or 2 marks out of 3 would be my guess, Zedalia. I think that they would want to see a couple of things. First of all, I think they would want to see the 1 at the front and the minus 1 over here. All right, then there would probably be 1 mark for that. So 1 mark on cos 0 equals 1, and that same mark on cos 180 equals -1. Then I think the second mark would be awarded on realizing the pattern. So in other words, the cos 179 is the cos of 180 minus 1, which gives us negative cos 1. So I think there would be 1 mark on that. And then I think, sorry, I've already put a tick for that. And then the last mark would be on the answer. So maybe they'd give you 2, but then you see the problem is that you just guessed. Maybe you just guessed that it was 2. So I think it depends on how the question was set, but I think I'd go with definitely not full marks, and I'd probably want to see the working to give you 3 out of 3.
Okay, thank you very much.
Okay,
ma'am.
all right, no problem, anytime. Where did the 1 in front come from? No problem, Jude. The cos of 0 is 1. Think about your cos graph, Jude. Okay, so the cos of 0 is equal to 1. Okay. Can you see how all the time when we're working here, we're always kind of linking back to graphs? Okay, when we understand the graphs, we understand everything. Yeah, okay, so that's where it comes. And same with the cos of 180. Okay, think about your normal y equals cos x graph. Okay, and that's why it would be -1. Okay, well, that was cool. We got to do a little bit of problem solving this lesson. So I'm really pleased that we've been able to have a look at some slightly more difficult questions. All right, so we've got 15 minutes left. Let's have a look at a graph question. Okay, and there's some nice challenging questions in here as well. Okie doke. So in the diagram, the graphs of f of x equals tan 2x and g of x equals 1 plus sine 2x are drawn on the same system of axes for x is greater than or equal to minus 135 up to 135. Okay, now, before we jump in and start answering the questions, what I want to ask you guys is these graphs have been transformed in some way. So this is not the graph of tan x, it's the graph of tan 2x. So what's changed from tan x to tan 2x? What's happened? I'm just going to go over these in green while you guys tell me the answer. How has the graph changed? Okay, so one person has said shifted. Pinga has said the amplitude is double. Anybody else? Is it a shift, which is a translation? Aha. Okay, good, Jude. There we go. All right, so Lucidi is saying period is divided by 2. Frequency, I understand what you mean by that, Jamie. Jude, okay, so what Jude has said was the most correct out of everybody. They changed the period of the graph. Okay, so instead of the graph repeating itself every 180 degrees, what's happening now? The graph is repeating itself every? The graph is repeating itself every how many degrees? Every 90 degrees. Good, Lesedi. Perfect. Good, Lesejo. Every 90 degrees. Can you see what that's done? So instead of us having our amplitudes at 90, we've now got our amplitude at 45, half of 90. Okay, so the graph is repeating itself every 90 degrees instead of every 180. Again, we've now got an asymptote at 135 when normally it would have been 270. Yes, correct, Penga. So amplitude changes when it's the coefficient of sine x, cos x, or tan x. So if I say 2 cos x, then I've changed the amplitude. Then my graph is starting at 2. Its maximum is 2 and its minimum is -2. Then I've changed your amplitude. So when you change the amplitude, you stretch the graph horizontally. When you change the period, you squash the graph vertically. Okay, all right. So that's the graph of f of x equals tan 2x. Now let's have a look at what they have done with the sine graph. Okay, so whoever did this question wasn't very imaginative. Can you see they've done the same thing? So we've got sine 2x, so it's a sine curve, but what does the plus 1 mean? What does the plus 1 mean? Obviously, the 2x means the pair. Oh, I'm drawing terribly here. What does the plus 1 mean? Good, Lesedi. It has been shifted 1 unit up. So in the second graph, in g of x, they have changed the period. Okay, so again, this graph, instead of it repeating itself every 360 degrees, it's repeating itself every 180 degrees. And they have shifted it 1 unit up. Okay, so normally it would start, would have a maximum at 1 and a minimum at -1, but now it's got a maximum at 2 and a minimum at 0. Does that make sense to everybody? Hope so. Okay. Let's have a look at the first question. So the first thing that they want us to do is write down the equation of the asymptote of f in the interval between -135 and 0. So that's pretty easy. That just comes from the graph. So what would be the equation of the asymptote in the interval that they gave us? In fact, I think there could be 2 answers here, which would be acceptable. Okay, so they just want us to look to the left of the y-axis. So the equation of the asymptotes are the vertical lines. Okay, so we could say x equals -45. Okay, they've told us we can include -35. So I'm thinking here they would also have to accept an answer x equals -135. Maybe they meant for that to be a round bracket, but anyway, it doesn't matter. They just wanted one answer. So let's go with this one, x equals -45. Does that make sense to everybody? It's the equation of the asymptote in this interval. So we would get 1 mark on our answer over there. Cool beans. Jude, you're saying no, why not? Okay, so from -135 to 0. Okay, the equation of the asymptote, there's 2 asymptotes. Okay, so either it would be the line x equals -135, or it would be the line x equals -45. Okay, so it's either this one here, Jude. Let's just get a different guy. Either it's this one, or it has to be this one. Okay, yes, the dotted lines, the asymptotes. Okay, so I'll just put the asymptotes in blue. Okay, because they're vertical lines, they take the form x equals. Now, let's have a look. We've got a few minutes left. Let's have a look at what they're saying in question 6.2. So if h of x, now h of x is a completely different graph, is the graph of sine x minus 2 sine cubed x over 2 sine squared x cos x, determine h of x in terms of f of x. Where do you think we should start? We're going to have to start with h of x because they want h of x in terms of f of x. What can we do to the numerator of h of x? What can we do to the numerator? There we go. We can take out a common factor. Absolutely. Because remember, we can't cancel across plus and minus signs. So if we see pluses and minuses, we have to factorize. So let's take out sine x. That's going to give us 1 minus 2 sine squared x inside our bracket. So yes, Adelia, then we would definitely have to go and look at our formula sheet. Okay, at the bottom, we have only factors. We've got 2 sine squared x times cos x. All right, so what's the next thing that we think we should do? We can cancel outside of the brackets. Sine x with sine squared x, that would leave us sine x at the bottom. Also, 1 minus 2 sine squared x is cos 2x. All right, now at the bottom, we've got 2 sine x cos x. And we know that 2 sine x cos x is sine 2x, isn't it? That's it. Well done. So now we've got cos 2x at the top, and we've got cos 2x at the bottom. Sorry, I'm talking nonsense. Beg your pardon. We've got sine 2x at the bottom. Sorry, guys. Right. So what happens when we've got cos 2x over sine 2x? Remember, sine 2x over cos 2x is tan x. What do we have now? If we've got cos 2x over sine 2x, what does that give us? That's it in Kanyiso. Chad, very close. Good in Kanyiso. Well done. We have 1 over tan 2x. Good. Well done. Okay, so it's a reciprocal. And if we've got 1 over tan 2x, then we've got 1 over f of x, because remember they wanted us to determine h of x in terms of f of x. So this would give us 1 over f of x, like so. Okay, does that make sense to everybody? So factors. There, I think, would be the marks. Yes. Oh, good. All